Alright everyone, so I believe the sound is working now. I have royally screwed up enough times that I now know how not to. So what we're going to do is we're going to talk about piecewise functions a little bit. We're going to get you guys familiar with writing the function, and then I'm going to also familiarize you guys with graphing them just a little bit. I'm just going to give you a head start for the homework and also for inputting things to this function. So we're going to start this over. Here we go. So functions, piecewise, let's start with 2 lines. So if these were, in fact, 2 lines, then you would have something like this and something like this, correct? There we go. So we would look at these lines, and you could either do point-slope form or slope-intercept form, either one. But either way, you would get that this line, let's call this line line B, and this line line A. You would get that line A is in fact can be represented by the line y equals x, because the slope is 1 plus 3, and that B can be represented by y equals x minus 2. Everyone seemed to get here in class just fine. So now let's talk about what will happen if we get rid of the rest of those lines. So as the graph was previously. Alright, so let's take this graph as it is here. So still, we have this line being represented by this equation, and this line being represented by this equation. I've color-coded them. But we have a bit of a stopping point. So at x equals -1, so that is this line right here, we have a point where they are stopping. So we have an open circle on the bottom, line B, and we have a closed circle on line A. The open circle means that there is no point existing there for that ray. So the ray B does not have a point at x equals -1. But if you will notice, all points to the left of x equals -1, which means x is less than -1, have existing points. Similarly, at the top here, we have a closed circle, which means that this point exists. So for the first ray, the point exists, but for the rest of the ray, we are greater than -1. So x is greater than -1 exists, but also x equals -1 exists here. So what does this mean for us equation-wise? This means that for f of x, well, the top part gives us that x plus 3 is what's representative of f of x. And that is only if we have this condition satisfied first. If x is greater than or equal to -1, x plus 3 works. And that is our f of x. But if we have, so if x is less than -1, we have that f of x is in fact equal to x minus 2. This means that our function depends on where x is. So if we throw an x in here that is different, it may lead us to use either the x plus 3 or the x minus 2. So let's go through an example now. So let's say that I want to find f of x when x equals a certain value. Then I could write that as find, and we'll do f of, let's go 2. Well, f of 2. So 2 is what we would replace our x with. So let's go ahead and go through the practice of replacing x everywhere in this top equation with 2. So we could write f of 2 is equal to 2 plus 3 if 2 is greater than or equal to negative 1. And f of 2 is equal to 2 minus 2 if 2 is less than negative 1. But you guys all know that 2 is in fact not less than negative 1, which means that we do not use this bottom equation at all, and we do use this top equation. Because 2 is greater than or equal to negative 1, we use f of 2 equals 2 plus 3, or we can simply write, because adding those, we get f of 2 equals 5. Okay. So that would be how you input a value into the function. Finally, I will briefly demonstrate a little bit of graphing here. So here we have some graphs, some a graph, and then a function to graph. So let's talk about one of these. So first, I'd like you to know this should be a negative 3, and for the homework, change that to a negative 3. This was a mistake on my part, as was most of this stuff, so I apologize. So let's use this magenta color, and let's graph this first part. If x is less than or equal to negative 3, then we use f of x is equal to negative 1/3 x minus 2. So let's start, because it says x is less than or equal to negative 3, let's start by using x equals negative 3. So at x equals negative 3, we're going to have negative 1/3 times 3 minus 2. So negative 1/3 times minus 3, is positive, right? And it's positive 1 minus 2. So I'll write this out. Minus 1/3 times negative 3 minus 2. Right? So this is essentially calculating f of minus 3. And this would be 1 minus 2 is equal to minus 1. So let's plot that point now. So we have f of x is equal to minus 1, and x is equal to minus 3. So we go over 1, 2, 3, and down 1. So this is that point. And we plot it with a filled-in circle, because that means that it is less than or equal to negative 3. Okay. So what are all the x values less than or equal to negative 3? Well, the x values less than or equal to negative 3 are all to the left here. Okay, well finally, if we're going left here, we would go up and back, or up and forward, because we have the slope is negative 1/3. I'll explain this a little more clearly. So the slope is minus 1/3. So if we go back 1, or up, ignore what I'm saying right now. I'm writing, right, overrun. Okay. So let's say we're going back 3. So let's use the yellow marker to signify we're going back 3. Okay. Well, if we're going back 3, we're also going to go up 1 here. So this will be our next point. And then from there, you can make a straight line. We'll use a black color, and we'll use an arrow. And so you start there, and there's part of our line. And so from here, I'd like you guys to graph, mistake there. I'd like you guys to graph following, wow, don't do this. Okay, I'd like you guys to graph the following, that, and then do the rest of the assignment that is posted on the Edmodo page associated with this video. Again, apologies for the outrageous amount of inconvenience that this has caused.